In this demo, we'll take a look at the performance characteristics of different loop styles, initialization patterns around them, and the effects of overall CPU time performance across averages. Then a quick look at some interesting facts about Apex tests themselves. How slow is it really to access the database in a test? How much faster is in-memory performance that only simulates the database instead? For the examples of different loops and their performance, I want to point out that everything here you can run for yourself from the course examples. At the top of the M5_fast CPU class, there's the setup accounts method, which simply puts 200 accounts into an in-memory collection. Below that, a while loop example. Of importance here is that the while loop runs while the current account variable, initialized to start at 0, is less than the accounts.size method call, which returns an integer each iteration. As mentioned earlier in this module, the performance of calling the size method takes longer because of reinitialization. The next example shows that of a standard for loop, which, again, calls the accounts.size method each iteration as a part of its for loop structure. You saw this method in the slides earlier in this module. And you also saw this one below, which avoids the reinitialization of the account list size by placing it into a variable, and then that variable is set as the value of j in the loop structure. Similar to the variable I within the loop, the variable j is being initialized in the beginning of the loop. Then, in the second part of the for loop structure, the condition simply says that the loop should persist while I is less than j. And then I is incremented as it normally would be. The difference, though, is that j, nor the number of accounts from the list, ever needs to be reevaluated. In other words, the integer value never needs to be reinitialized. If I run the associated test class loop speeds test, then I receive back the execution of each of these loop types. The test runs all three loop styles and prints out the CPU time in milliseconds for each. As you scroll, you'll notice that each run shows an inconsistent value. At the end, there's also a total and average printout of each of the loop styles. The optimized style that avoids reinitialization appears to be the fastest. Very interesting. Initialization, or the lack thereof, is so incredibly important that it has a major impact on how fast Apex tests themselves run too. If I run all the tests for the course examples using the Salesforce CLI, I get a breakdown of test times. You'll notice that tests that actually perform actions on the database take substantially longer than those that do not. You can go through each of these tests for yourself and compare. Look at those that perform DML, like inserting records, and compare their speed with those that do not. You'll discover, consistently, that the in-memory only tests are very fast. If you can spare some DML in your tests, you can benefit not just the avoidance of governor limits, but also the decrease in waiting for tests to run too. One more thing, and this is kind of weird. Here in the M5 Fast CPU test class, I have a test called Completely Empty Test. According to the Salesforce CLI, it still took some number of milliseconds to run. Isn't that weird? This means that part of the time you wait for Apex tests to execute at all is variable. There could be absolutely nothing in the test, and it's still going to consume some kind of overhead. At least, that's according to the CLI. Figuring out what affects speed and performance in software is one of the more enjoyable parts of being a programmer, in my opinion. It's remarkable that in these tiny fractions of a second, so many things happen. Try your own experiments with Apex, and you might discover more useful things you can use in your own work. Next, let's look at how we can affect heap size in Apex.